All right, great. Well, thank you guys all for joining. I'm really sorry that we can't actually be together in person live, but this is kind of the next best option is Zoom, which I'm sure you guys are all super familiar with by this point during this crazy time. I'm Abby Delaney, and I am the marketing manager at BigRep, and to welcome you all to our virtual demo. Next, housekeeping, we will do Q&A throughout the demo. So Chris will go printer by printer, and after each printer, we will pause for Q&A. The goal of this is to really be interactive. And like I said, since we can't actually be together, we want to try to make as much interactivity between you guys as we can. So we'll have a few polls. Chris was live. The whole thing is live. So we will apologize now if something happens, but we are really live, and that's kind of really important to us so that you can see everything from this view. And so I think that is all from my side. So I am going to go ahead and turn things over to Frank.
Thanks, Abby. And again, welcome everybody. My name is Frank Marangella. I'm the U.S. President for BigRep America. And happy to have you here. As Abby mentioned, we would have loved to have you at a trade show. Unfortunately, the current environment is not allowing us to do that. So thank you for joining our virtual demo. We're not going to waste too much time here today. I wanted to just take 1 minute out just to introduce you to BigRep. I have no slides, just a little bit of a description. BigRep was founded in 2014. I don't know if you know that. It's a Berlin-based company. From the beginning, started on large format plastic extrusion systems. That's all we do from 2014. We have more than 500 installed systems globally. Our 500th customer happened to be a customer that has 4 systems making end-use part covers for water skidoos. So we're pretty excited about that customer and our 500 customers, but our customers are doing a variety of things. We have a lot of Fortune 100 companies that really are pushing the limit of extrusion technology. Large format comes in a lot of benefits, and Chris is going to explain some of those today when he gives a demo, so I'm not going to talk about that. We started in the beginning as a global company. So from the start, the company opened an office in the U.S. and in Asia. Our U.S. office is where Chris, Lee, and Amnon here are today, which is just north of Boston, Massachusetts, Wilmington, Mass. Our Asia office is in Singapore, and our Europe is in Berlin with our headquarters. And last thing for me, to make a successful subsidiary, which I've been doing for a long time, you need to have all of the structure and support locally. So we are a Berlin-based, German-engineered company. We're proud of that. But to make it successful, we need to have the logistics here. So if you need a spare part, Saratech can get it from our storage location. We have a storage just near our office in Peabody, Massachusetts. When you buy a system, you buy it from our Massachusetts warehouse, a spare part. Our filament, our shop is a U.S. shop, and the stock comes from our U.S. warehouse. Sales, service, customer support, and logistics all need to be local for this relationship to be successful, and that's what BigRep has done from the beginning. So from that, I'm going to end here, turn it over to you, Andy Dio. Tell us a little bit about Saratech yeah.
Sure. Thanks, Frank. And thanks, Abby and the BigRep team for working with us on this live demo. I'm really excited. Like Frank said, this is the best thing that we can put together without being able to do this live in person. But my name is Andy Dio. I'm the VP of Marketing at Saratech, and we are an engineering company based out of Southern California in Mission Viejo. But we do have sales and technical people all across the country. And we work with top-tier OEM like BigRep, like Siemens, to provide companies that are in design or manufacturing with the tools that are needed for product development. And one of the key thing that I want you to know is that Saratech, we don't just sell the product. We are an engineering company. So we have our own development in-house, and we actually use the tools, the software, the 3D printers, in-house in our own product development. So we understand those challenges from a customer standpoint, and we work with a lot of customers across the country, from small size organization to multinational companies, and helping them with optimizing PLM, optimizing product development, and 3D printing. So I'm glad you are able to join us today, and looking forward to eventually, hopefully at some point, meet all of you.
All right, great. Well, Chris, this is your kind of 2-minute warning here. So before we go live over to Boston, we're just going to launch a quick poll here. So just looking, are you currently 3D printing within your organization? Yes, no, or unsure? So this just kind of helps Chris and Andy and Frank with their discussion as we kind of continue along here. So results are coming in. It's pretty split, half and half. Yes, no's. Right now the yeses are taking the lead. We'll give it a few more seconds. Get your votes in. One more, anybody else? All right, let's end this poll here and I will share the results. So about 60% said yes, you're currently printing. 40% said no, and I'm really glad to see that nobody's not sure. But so that no category there, we'll see if we can sway your mind there in terms of that. So thank you for answering that. And with that, we're going to go live over to Chris. Are you there, Chris?
Yep, I'm here, Abby.
All right, there's Chris. It's all you.
All right, good to go. Thank you, Frank. Thank you, Andy, for the introductions. My name is Chris Lee. I'm an application and technician for BigRep. I'm accompanied by Amnon Hamami, our operations and service manager. We'll take about 5 minutes to go through each printer with Q&A in between each one. From there, by the end of it, hopefully, as Abby said, we'll get everyone as a big yes for 3D printing. So the first machine we have here is our BigRep 1. As Frank mentioned earlier, BigRep has been around for 6 years. This was our flagship machine. This current model is the 3rd generation of the BigRep 1. We call it the BigRep 1 due to its large build volume of 1 cubic meter, hence the 1. As you can see, it offers a dual extrusion capability. So if you wanted different colored parts, different material parts, maybe different processes all within a single job, because of the dual extrusion and our slicing software, which we'll get into later, we have a lot of versatility and flexibility on how our customers can print what they need. So in terms of quality and resolution, we offer various nozzle sizes on our dual extrusion, anywhere from 0.6 millimeters all the way up to 2.0. So depending on how fast you want the print to go and how good looking you want the print to go, you have the options to go 2.0 really fast, may not look as good, but if you then go to a 0.6, it may take a little bit longer, but it'll look a lot better. The gantry itself, you can see, is well engineered. We love our German engineering. That's what we've stuck by. That's what we trust. And
I think since we are live, I think we've just maybe, Frank, are you still there?
Yes, that's
okay.
First time that's happened.
First time that's happened. All right, I'm going to figure out what's going on. Frank and Andy, why don't you guys maybe address a couple questions here we've got. What does large format mean, and why is it important in today's 3D printing industry?
Yeah, Andy, let me take that first, and I'll let you comment on that. I love answering the question because people look at the BigRep 1 that Chris was just looking at and saying, oh, 1 meter cubed, I don't have parts anywhere near that size. But we find the benefit of using a large format printer to have the mostly flexibility. So large format really is those parts printed that are bigger than basically the alternative. So the desktop printers are 200 or 300 millimeter square and cubed, and anything that needs to be bigger can easily be printed on a large format. But sometimes you have one dimension that is bigger, so that having the flexibility to lay it down in a certain way and be able to print that one dimension, or sometimes you have one dimension that you need to run in the X direction.
Yeah, how you can make this one big.
And the last thing, before it sounds like you're ready to go back to Chris, the last thing is like when we were printing the shields during the PPE in the beginning of this pandemic, You could print one off on a desktop printer, but we could print 50 of them at one time. So you could push print at the end of the night, go home, and then come back and you have industrial level production. Andy, any addition to that before we go back to Chris?
Yeah, I mean, we talked to a lot of customers, and really, the size, the print envelope is sometimes the limiter, right? So with a large format system like what BigRep has, it kind of removes that thought restriction that people have when you're looking at design part, when you look at how you approach something. So it really gives you a lot of freedom when it comes to creating or designing parts for what you need to do.
So everybody is right.
All right, great. It looks like Chris is back now. He is back, but now he's sideways.
We're also sideways? All right. Like I said, we said this is live, and we also have a tropical storm coming in, so I'm sure that's not helping our connection and our router.
Good answer. Good answer.
Yep, you're better now.
Look better on your end? Perfect.
Yep, perfect.
So where'd you guys lose me?
We heard about the nozzle size. I would say that was maybe the last thing.
About the nozzle size. Okay.
We lost you a while ago.
Well, that's okay. I'm not with the story every time I say it. So, like I said, the nozzles anywhere from 0.6 to 2.0 millimeter diameters. So what that allows for is a variety of resolutions and speeds. So based on how good you want the part to look versus how fast you want to get it, we have those options to really allow the customer to make it as ideal as they like, whether their priority is the speed or else the quality. Like I said, it's live, so we do have a phone call coming. You want to tap that, Emma? Thank you. So the gantry itself is controlled by the Nanotech step motors in the XY as well as the Z. With the large plane that we're dealing with, it does take a lot of engineering, a lot of German engineering to be able to get the quality, the throughput of layer 1 versus layer 5000. And as Frank mentioned earlier, that German engineering is really what we strive towards and what we use to succeed with our models that you'll be seeing. The positioning tolerance of the motors is 100 microns in the XY and then 20 microns in the Z. So even over entire build plates, you're going to get very accurate, very repeatable parts on BigRep 1. So if Emma wants to take us to the backside of the machine, we'll talk a little bit about materials and material handling. So BigRep offers a wide variety of BigRep certified materials, anywhere from TPUs to PLA to even some carbon fiber materials. Outside of that, BigRep has a open material platform. So all of our materials, it's the 2.85 or 3 millimeter diameter filament in these large spools here. BigRep sells spools anywhere from 2.3 kilograms all the way up to 8 kilograms. And then depending on the type of material, so this guy here is your standard PLA. The material in the box is our BigRep TPU called ProFlex. The reason why we have it in the box is to make sure moisture and humidity stays out of the material and just outside the environment. That way we're not getting any weird quality issues or missing parts during the print, just to ensure that everything will print well and you're not going to be getting any clogs or weird issues along the way. So some safety features and other quality of life features that the BigRep one has. Obviously, the out of filament sensor is required as you're running 2-day, 2-week long builds. Once the machine recognizes that there's no more filament, it will give a pause sequence to the machine, allowing the user to feed on more material and then continue to print like nothing. The user panel is Linux-based, pretty straightforward when it comes to your prints, getting them set up. You can either do USB upload, or if you have the printer on Ethernet, you can upload the jobs on a separate computer. You cannot start them. from that separate computer just because of the safety requirements. You want to ensure that someone's always in front of the printer before you press go. One thing I forgot to mention was the bed itself. The bed is 1/4-inch aluminum, and then the orange sheet that you see on top is a polyamide that we call Kapton film. So what that Kapton film does is two things. It protects the integrity of the bed, and then it also helps with material adhesion for certain materials. So part removal, the bed gets upwards of 60 to 80 C. When that cools, once a part is done, it releases the part from the bed. Sometimes we also use a 3D printing adhesive called Magigoo. So that Magigoo, it is water-based. So between the thermal process of the bed cooling, as well as using a little bit of water to release the Magigoo, it really doesn't take much to get these big parts off the bed and making sure that they're still level and flat. Yeah, that's a good intro so far. Abby, any questions from the audience?
We do have a few questions. You did talk a little bit about materials. Can you just talk a little bit more about what materials are available on the one?
Yeah, so the one very clearly is open to the environment. So materials like ABS, nylon, ASA, because when you print them at a large scale, they do release toxic fumes. On this machine specifically, they will not work, but we do have a couple other machines that will allow that. So on the one, it's all of your more standard materials. So I can grab a couple pieces. The black material that is on there now, like I said, is our Proflex, our TPU. And then we have an ABS-like material called Pro HT. I think Pro HT is our most versatile, our most used material because it has very similar thermal and mechanical properties to ABS, but it doesn't have the same toxicity. We definitely sell that and use that the most on our printers. And obviously, it prints very well. We can do this single extrusion with support. The support removes very easily afterwards. And then it's also compatible with a couple different materials for dual extrusion. So we've done a few parts where it was like a live hinge for a car door or something. We would have the TPU material function as the hinge, and then the Pro HT be the load-bearing part, have that print in high infill percentage, and we would do that all in one go because of the dual extrusion, and that was a cool project on the one.
All right, great. This is an application question, but I'm going to let Chris handle it, and then I'll let Frank maybe jump in with a little bit more detail. It says, structurally, how durable are the parts? If you're a furniture manufacturer, can you sit on a part and it not crush it?
Yep. I think one specific example was, there we go. So this guy here was printed in our BigRep POA. Again, POA is your most standard polymer for FDM printing. This is at 8% infill. We tested this a while back. Takes about just under 1,000 pounds of vertical force before it actually buckles. So I think you, me, and Amnon all sit on that together before this thing breaks down and all that. So we have other customers do larger pieces of furniture outside of this small stool here. We've done anything from one-to-one couches, bath fixtures, really anything you could imagine. I mean, I am moving into a new apartment in about a month, so I have been thinking about printing stuff. So if the machine's down, I may do a stool or two in my place. So.
Nice. Okay, next question. Can you explain the semi-automatic bed leveling?
Yep. So another requirement of a bed this size is to ensure that each point from one corner to the other is all in the same Z-plane. So in order to get that tolerance, we have a inductive sensor next to the extruders, pretty much like a fancy proximity sensor, to where it reads various points around the bed. And then underneath the bed, we have a couple legs that we use for adjusting. It'll go around the bed a few times. We make those adjustments to plus or minus 0.02 millimeters. So to put that into perspective, it's about half the thickness of a human hair. So very tight tolerances, and after we do this a couple times during installation, there really is no need to do it again unless you're moving it from one location to another.
Right, great. You mentioned 2 nozzles. Is 1 nozzle for support and 1 for the part, or is it possible to print 2 materials and make a hybrid part?
Yep, it is possible. So as I mentioned with that live hinge model, you could have Pro HT on one nozzle, TPU on the other nozzle, print them in the same part, or maybe you wanted to do one model in Pro HT and then an entirely different model in TPU, you can do that as well. So instead of having that loss of time or changeover, like if you wanted to start a print at 6 p.m. and it's only 6 hours, well, you're not going to come in at midnight. So you can just add on the second build, the second part in the same build, and then have it do both of them, single extrusion, and then you won't have that loss of time that you would in the night.
All right, great. What's the max weight that you've printed?
Max weight? We use max volume. Amazon and I, we've done a couple where they pretty much max out full X, Y, and Z. If I had to guess how heavy it was probably 2 or 3 spools of material. So anywhere from 20 to 24 kilograms heavy. So it took Amnon and I together to get that thing off. And yeah, we can get some large parts, definitely.
All right, great. I think that's all the questions we've got for the one. Let's turn the camera there and walk over to the Pro.
Okay, perfect.
I lied. One.
Machine,
I'm sorry. Wait, one more just came in.
One more?
Yeah, sorry.
Okay.
One more snuck in. Can you enclose the one?
You can, yes. Because the one's been around for about 6 years, we have a couple different options for enclosing it. One that we sell, and then if some customers want to do their own little custom enclosure based on their warehouse safety requirements, we've done a couple side projects with them to make sure that it's well sealed and it'll still print well for whatever materials they want to run. So like I said earlier, we are open source with our materials, and then through Saratech, we'll have the support to get those materials running as well as possible, whether they need an enclosure, dry boxes, whatever it may be.
All right, sorry, there's another one just came in too. Can the BigRep 1 run over the weekend and finish a job without somebody being there to monitor it the entire time?
Of course, yep. We've had these guys run 7 days, 14 days, Our spools are upwards of 8 kilograms. I've had some customers use 25 kilogram spools. So you could have that thing run for 3 weeks straight, not care, and have a giant part done when you get back.
And is there a way to monitor it remotely?
Yes. So you can get the printer on Ethernet or Wi-Fi connection. So in addition to the remote job upload, we do have a Octoprint webpage where you can monitor the job via a webcam, which also comes as an accessory. And you can also see the G-code in a way to figure out how much has been printed of the G-code size and then how much is left. So that'll gauge roughly how much is left in time. And then also tell you in hours, minutes, seconds, how long it's been running.
Okay, now it's safe to go.
All right. I'll go slowly in case anyone has any more questions.
And hopefully we'll have time at the end for a few more questions.
Yeah, we got plenty of time.
Yeah.
All right. So this guy here is the BigRep Pro. The BigRep Pro is, I think, a huge step from the BigRep 1 in terms of throughput, material, and then just the amount of data that we're able to process with these builds. So the 2 main reasons for that, one is a new type of extrusion technology called MXT, and then pairing that with high-end CNC control systems from Bosch Rexroth, that allows us to do some pretty cool things. So first off, the MXT, with the BigRep 1 and with most industrial 3D printers, the limiting factor on how fast you can go is the thermal process. So you're always having to wait for your material to feed in, heat up, and then extrude out. With the MXT, we now have a small pool of pre-melted filament so that you're no longer waiting on that melting process. Now the limiting factor is actually how fast you can move the extruders and the gantry back and forth, to still maintain quality. And then next, it was the CNC control system. So with Bosch Rexroth, we're able to just gather so much data, anywhere from XYZ location to temperatures to extrusion rates to fan rates, flow rates, everything. So with that in mind, once we have all that data and we're able to understand that data, a project could come in, you need 100 units. You need to understand what's a good unit, what is a bad unit. And with the data that we have, the machine will know and the machine will tell us, is this in spec? Is this out of spec? What is our spec? What does spec mean? You can dictate what your spec is, whether it's XY location, maybe you don't want it to go too far away, things like that. So just a little bit under the hood. So if you don't want to use the MXT, the reason why customers don't is that at this time, the MXT is just a few materials right now. Because of the new technology, it does take a little bit longer for R&D to fully certify materials. If you want the range of materials like the BigRep 1 plus a few more, we have a ACE extruder, same nozzle sizes as the 1, 06 or 2.0. In addition to the materials that I mentioned on the 1, because the print chamber is enclosed, because of the ambient heat coming from the bed, we can print things like ASA, ABS, nylon, PETCF, so your carbon fiber. And then based on the material combinations you want to do, you can do 2 MXTs, 2 ACEs. It takes maybe 5-10 minutes to get them changed out. And then again, you have that flexibility, the versatility of all the hardware options we have. And then there's always a perfect solution to whatever application, to whatever job you want to get printed. And then another couple of features, you have the webcam, which comes standard with the BigRep Pro. You can see the higher end control systems, the motors in the back. So right now, we do have 2 ACE extruders on the printer right now. This model here was printed in our Pro HT. That was the non-toxic ABS single extrusion. The reason why we did single extrusion is that with the Pro HT, these supports will come off quite easily. Because we're using engineering grade materials, we need to have a more concerned effort on pre-processing of those materials. We have a heated chamber on the left here, and then a not heated chamber on the right. You can switch them out depending. Heated chamber over here, as I mentioned, this would be for your TPUs, your water soluble supports, anything like that. And then on the other side, you would have your Pro HTs, your PLAs, things like that, just to make sure the quality of the prints are as good as they can be. So just a little sneak peek under the hood, just to show you the complexity of the machine and really the backbone of what we're working with. So we've had the Pro for maybe a year and a half now, and I think even at this point we're just getting our feet wet with the throughput and the amount of data that we're grabbing from these controllers. So comparing the 1 to your standard industrial printer, probably 1.1, 1.2 times as fast. If you compare the 1 to the Pro is already 2 to 3 times as fast as the 1. And I think, very soon will be upwards of 3 to 5 times as fast, at least. So the Pro does have the magnetic interlock doors just for your extra safety, so no one can gain access while it's printing. And then the Pro HMI. HMI is the human machine interface. This is run off of Windows, so it's a bit more user-friendly for our software guys. It makes it a lot easier for software upgrades. As soon as they get rolled out, we'll be able to remote into your machine and do those updates, same day. And like the one, you can get it on Ethernet or Wi-Fi connection and be able to remotely upload jobs and then monitor the job's progress with the onboard camera. Because of the wider range of materials, the bed can get upwards of 80 to 90 C. The one is about 80 C at max, maybe 75. And then the nozzles are upwards of 250, 300 C. Any questions?
We have a few questions. What is the power requirement for the Pro? And I guess while we're at it, maybe what is it for the one as well?
Yep. So both the one and the Pro are 208 to 240 volt. The one is a 20 amp plug, whereas the Pro is a 30 amp plug.
Great. What's the approximate footprint of the Pro?
Footprint, so I'm about 6 feet tall. So it's 6 feet-ish tall, maybe 7 feet wide, and then about 8 to 10 feet back. So it's a big machine, with the large build volume and then the larger electrical cabinet in the back. It needs a space.
Do you have a part there that you could do a comparison of time print on, of what it would be on the Pro and the versus the one?
Yep. So mentioned it was 2 or 3 times as fast on the Pro compared to the one. So for example, this stool here takes about 24 hours in our Pro HT using a 1 mil nozzle on the one. If we used a 1 mil nozzle on the Pro, it would take about 12 hours.
All right, great. I'm not sure that you have this data handy, but how does the accuracy of a print on the Pro compare to that of an SLS printer?
On an SLS, so it is different technologies. So like I said, with the one, it's 100 microns XY, and then 20 microns in the Z. With the Bosch, it's maybe 15, 20% better. I mean, we're already at really tight tolerances. I think we're at 4 thou on the one, so probably 3 thou on the Pro. I don't have the direct comparison with the SLS at this time, but we can get that for you if you really need the answer.
All right, great. Okay, next question. If I have a production injection molding material such as ABS, is it possible to formulate it to run on the Pro? And if so, how hard is it?
Yeah, so when you transfer over an injection molded part to FDM, one of the biggest differences we see is the wall thickness. So with injection molding, you're able to get thinner parts, and you're able to get the mechanical strength within X, Y, and Z about the same. With FDM, we unfortunately don't have that luxury. We can get it, pretty comparable based on the material, but it's not perfect. But what we have with our slicing, and then with our machines, we can either increase the thickness, or even working with the resellers and BigRep, we can transition that part from injection molding to design for FDM, so it'll print very well and still get the same output that they're looking for.
Okay, just follow up on that one. More to the material properties, or maybe, and Frank can talk to it too, customers that are printing injection molding instead of traditional manufacturing?
I mean, if it's the same strand of ABS and it comes in a filament form, we're more than happy to print it, and it should function in the same way. But like I said, the mechanical strength, whether you print it in the X, Y, or Z axis, one side will be stronger than the other. So that's the only consideration when you're swapping over. And
Andy, we can follow up with you after if you've got a part you want to send Chris and team. We'd be happy to take a look at it for you. I'll give you them. They can help you. Any more questions on the Pro? I think we've got most of them answered. just for time, I want to make sure we get to the G2. So let's keep walking.
Yeah. So the last machine that I'll be showing you today is the little baby of the bunch, the BigRep Studio G2. The G2 is the second generation, obviously a step up from the G1. The G2 is fully enclosed, similar to the BigRep Pro. It has the same control systems as the one. So you're not going to have the same speed as the Pro, but you'll have the same material output as the Pro. So the build size on the Studio is 1 meter long by a half meter wide and a half meter tall. Similar to the Pro, it has heated filament chambers. So you have your controls here for T0, T1, or 2 nozzles, as well as the chamber itself. We do have active cooling on the upper end of the printer. If it does get too hot based on material, so like for example, PLA doesn't like a whole lot of heat, so we would set our print chamber low. But if we're doing carbon fiber or an ABS, we would set our filament chambers here to like 35, 40 C, have that dry out, and then we would set our print chamber to a higher temperature so all that heat is contained, and you'll get a nice smooth print for that higher grade material. The bed is the same configuration as the one and the Pro, 1/4-inch aluminum with that Kapton film on top. So the Kapton film is actually a consumable item in that over time, depending on the customer and the parts and how they get removed, that does get damaged based on how they remove parts. The good sign or the good thing is that it takes about, I don't know, $100 worth of material and then half an hour to replace it. And then you can use it for 6 months, a year, again, depending on how patient you are to remove the large parts. And although we don't have it on board right now, there is a camera similar to the Pro that comes standard. So you can get it on Ethernet and monitor everything, make sure it's printing well. So what we have going now is actually just a large volume of print samples that we'll be sending out to all of our resellers, just making sure that all of our new materials are well known and resellers and customers can have them readily available to field them, go through bend tests, and just make sure they know what they're getting before they get a machine. And then lastly, with the G2, it has the same PC panel like the BigRep one, so you can go through all of your print menus, your temperatures, controls. So with any installation, we'll be there anywhere from a day to 3 days, depending on the customer's preference and ability. And we'll go through anywhere from slicing training to calibration to maintenance, whatever's needed on their end. So on the topic of maintenance, on the day-to-day, there really isn't a whole lot. Once the bed is level, it pretty much stays for a very long time unless you move it. The biggest concern for maintenance is maintaining grease on the spindles and then making sure there's no dust or leftover debris on the build when you start a new job, just to make sure you're not going to get any collisions or issues with that.
All right, we got a few questions. What is the print speed in millimeters per second on all the machines?
So that does vary, but based on the nozzle size as well as the resolution. In general, the more material that you're feeding out at one time, the harder it is to control. So in general, the slower we would go. If we were doing a 0.6 nozzle, which is standard on the G2, and we can get anywhere from 100 micron layers, we could push that to about 120, 140 I've used before, millimeters a second. But then on the 2 mil nozzles, we can do 1.1 or 1.2 layer heights, and that we can push at maybe 40, 50 millimeters a second. But because we're doing 10 times, as many layers compared to the 0.1 to the 1.2, overall the throughput would be better on the 2 mil nozzle because we're not having to do as many loops in the bed.
What about build failures with power outages? What happens?
Mm-hmm. So during installation, what the technicians do is calibrate the Z-axis. It will count the amount of steps going up and back down, and that is then stored in the printer. And so in the case of a power outage, when you turn the printer back on, you will be prompted with a notice. Do you want to continue the job where you left off? As long as you don't move the extruder in the XY, what the printer will do is go all the way up in the Z, count those steps, go all the way back down, remember where it left off in the G code, and then continue.
And what is the temperature range for the base and the chamber?
So the print bed on the G2, upwards of 80 to 90 C. The chamber itself is not actively heated, but because of the ambient heat from the bed, because it's so large compared to the actual chamber, the print chamber can get upwards about 40 to 45 C. And then if it does get a little bit too hot for what we're looking for, we have the cooling system, the fans up on top that will feed it out. And then in the back, we also have ventilation if you need to get out the toxic fumes if you're printing ABS or FCF.
All right, great. And I see you've got one good part sitting there for this question. It says, what about surface finish and any post-processing steps?
Mm-hmm. Let's see. So this guy here, I think I'm not grabbing some more stuff. So this guy here, if you can get a basic, well, this is PET CF, I believe, a 0.2 or a 0.3 layer height. Something like this is about the same, maybe a 0.2. So this is no post-processing. Almost all of our materials are pretty easy to sand them, prime them, and then paint them. For example, we have a part up here. So this is one example of a post-processed part. So you can see actually on the back end, this is the end that the user does not care about. So just to show you the FDM on the inside, and then on the exterior, you have this paired with the nice cushion. You can get some really good looking parts, and we can show you a couple more that we have in the office. I think one of my favorite builds is the F1 car here, printed in 3 pieces, left, right, center, a little bit of sanding, priming, painting. You can get a really cool 1-to-1 scale model like this. If you're looking for more heavy duty chemical resistant parts, we do offer metal plating like we have in this manifold here. So if you're pushing maybe a viscous fluid through here and you don't want to mill this out, we obviously 3D printed it and then nickel plated. This is pretty lightweight compared to a CNC part. And because you're just concerned about the chemical resistance, this does exactly what you're looking for in quarter of the time, 10th of the cost.
All right, great. One more question. This is Maggie. I'm giving you the 1-minute warning here to go to get ready. Last question is, how often do you have to replace the nozzles?
Depends on the material. Pro HT, we've had machines run on the same nozzle for about a year. If you're doing materials like PET CF, it does take a little bit more of a toll on the hot end. So our hot ends are hardened steel, so they're meant to withstand rougher materials like that. So I mean, we usually have customers with every 6 months, more just preventative maintenance. Yeah, they're meant to withstand for a while, and they do.
All right, great. Well, if we have any time at the end of this, we'll take a few more questions, but I'm going to launch one more quick poll here while Maggie gets her computer set up to do Blade. So next poll question here, let's talk about some challenges. So what is your biggest challenge, those of you that are printing with additive? Material, speed, size, budget, or you're just not sure? Right, people are voting, they're coming in, lots of challenges. So far, budget is leading the way here. We'll give it a couple more seconds here. Get your votes in. Maggie's ready. 3, 2, 1. All right, let's see. There's results here. So budget is the biggest challenge with additive, followed by material, speed and size, and then kind of unsure there. So thank you for that. All right, Maggie is coming to you live from New York. Somewhere there, I think.
Hi, how are you? Yeah, I'm here in Brooklyn, New York. I'm just going to talk to you very briefly about Blade, our in-house slicing software. So Blade has been developed for the last couple of years in Berlin with our R&D team, our engineers team, and our materials team. So essentially, we wanted to come up with an option for an easy-to-use slicer that was made specifically for large format printing, and then even more specifically for BigRep machines. It allows great control for your printing. We provide you with all of the presets. A few things you'll probably notice, it has a bit of a similar layout to Cura. So if you're familiar with Cura, this will probably be an easy program for you to adapt to. The biggest part of Blade and the biggest step that we wanted to make from using a third-party software was to really get accurate print time and material usage. So optimizing your prints to the maximum capacity. So as you can see here, I'm looking at the Studio G2. We do have on the left here all of our machines. So once you download Blade, which is free on our website, you're able to load up all of the machines that BigRep produces. But for now, I'm just going to work with the G2 since that's the machine that Chris ended with, and we're actually going to look at that manifold part that he showed you. So right now I'm in the prepare view. You can have a look up here also. I'll very quickly go through sort of the layout here. This is your dual extruder. So essentially this is where you would select your material and tell it which extruder you're using. So with the Studio G2, it's a 0.6 nozzle only, so that's why that's our only option here. But you do have all of these materials, and it will let you know with an error if a material is not compatible with that specific machine or nozzle size. And then you can also set material for your second extruder if you decide to do a dual extrusion print. Otherwise, you just have your basic tools over here in terms of scaling, movement, rotation. The other thing that's really special about Blade is its batch printing. So it is able to do batch printing. If you load up one STL, you can fill the whole build plate automatically with that part, and it'll fill it in a way where nothing is going to crash and nothing is going to happen. You can fill it up for printing all parts at one time or for printing parts one at a time, depending on what you want to achieve. And then the other thing that's really special that was an added feature in Blade is also the orientation, the automatic orientation of your part. So if you're not sure the best way to print your part in terms of saving on material costs or saving on print time, this program will actually do it for you. So I'm going to just switch over. I've already sliced the part. I'm going to switch over to preview mode. So now you can sort of see what it's going to look like on the bed once it's printing, or rather when it's finished printing. Over here you have, I won't go through all these, but essentially these are where you would also select your layer height. As I said, everything is preset for you and done by our team. So selecting your material, nozzle size, and layer height is essentially all you have to do. If you have more experience with 3D printing and you have a really specific part, you can go in here and you can start to play around with things. There are very interesting options that are available to you. And then the last thing, so as you'll see here, I have it actually in the color scheme line mode and the view type of layer view. So you can actually watch and see how your print is going to build up. So if I just zoom around here, everything is color-coded, and you can click on this and it'll tell you what those colors actually mean. There's keys and explanations for everything. And then, yeah, you can slice down here on the right-hand side and just watch how your part builds up. So it's a really great preview as well to see how your part actually is going to look like. It gives you an extremely accurate time estimate, and it also gives you the amount of material you're going to use. And it breaks it down even further than that. So if you hover over that info button, it tells you what each aspect of your part and how long it takes. As well as if you do a dual extrusion print, it'll break down the two materials usages for you. The last thing is, yes, just saving to file. As Chris mentioned earlier, if you're connected directly to your machine with Ethernet and with your laptop, you're able to actually just load through that Wi-Fi connection, or network connection rather, I should say, your G-code onto your machine. Otherwise, you would save file to USB, and then you would bring it over to your machine and upload it. So that's about it, I think, from me, unless anyone on my team has anything to add, or if there are questions.
We do just have a couple of questions. One came in, do you have to use Blade?
You only have to use it for the Pro machine due to the MXT technology, which is unique to BigRep. Otherwise, you can use other third-party softwares, and we do still have files for Simplify 3D if you decide to go that route. But Blade is free. It's what we work with, so we do highly suggest working with this program.
All right, we had one more question. What would a typical upload time be for this manifold example?
I'm going to assume you mean upload onto the machine in terms of G-code. To actually slice the file, it takes about 30 seconds, and it's the same for uploading onto the machine. It's going to be a really quick upload. I think the longest upload I've had was a part that maybe used maximum build volume on the one and was an extremely complicated mesh, and that maybe took a minute.
Okay. All right, great. All right, so I've saved one question for Andy and Frank. I'm going to launch our last poll here as we kind of go into our closing session here is in terms of applications. But what application are you currently 3D printing? Prototypes, tooling, patterns and molds, end-use parts, something else, or you're not printing yet? Let's see what everybody's doing out there. Last poll question, I promise. Got to make sure you're all still awake. I'll give a few more seconds here. All right. I'll just, one more coming in. All right, let's end this here. We'll share the results. So prototypes is the number one, and the second one is tooling for jigs and fixtures. So thank you all for answering that. And that ties very well into our last question that came in a while ago from Michael, and I told him we'd get to it, but he says, what have you found to be the highest and the best uses for each printer?
Sending that to us?
I'm sending that to you guys, yeah.
Fantastic. So the higher end printers have more flexibility. They do cost a little bit more. They're a little bit more detailed and precise, but they're able to run more accurate and higher end materials. So it's really what you want to do with it. Are you looking for volume, high-end functional prototypes that you need a particular mechanical property? Then that's the Pro and the G2. The Pro can do it in a bigger footprint. It can do it faster. It has better system controls with the Bosch Rexroth. So if the systems run perfectly and you have the nozzles and using the materials and everything is running as it's supposed to, you know, the G2 and the Pro have similar results at similar nozzle and layer height outside of speed. But the Pro has so many other features on top of it. The one, and we're enhancing the one all the time. Soon we will have a hardened nozzle for the one, also with the ability to run more engineering materials also. But having the open frame machine does have its limitation. It has great access, but some limitations as well. So that's my answer. If you're just looking for a simple PLA print, or you're looking for a bio ABS and the environment is clean, so the open machine, the BigRep one fits just fine. The Pro and the G2 do much more engineering solutions and higher end materials and geometric accuracy and higher spec. Andy.
Yeah. Also, the thing that I want to point out is a lot of time people just think about end use part, right? But there are a lot more applications for 3D printing than just end use parts, right? There's jigs and fixture, tooling, work holdings and things like that. So it really depends, like Frank said earlier, what your needs are. And working with a lot of customers throughout the years, I guarantee you, if you are doing production and if you have a shop running, we can walk through with you and find applications for 3D printing within your shop floor. A lot of time, because companies and people are thinking about things a certain way, you don't see the application or how you can approach using 3D printing in different ways to kind of maximize its benefit. And we work with a lot of companies and walking through and see what they do. And there's always one or two recommendations that we can make for 3D printing that is applicable to what they're doing today.
And Andy, I just want to say that is a perfect reason that BigRep and Saratech are partners, because you're an engineering company and you're not trying to sell a box. You're not trying to sell a printer. You're trying to sell a solution. And for the past, year and a half or so, BigRep is evolving from a system provider to a solution provider. We have an engineering solution team. So along with Saratech and BigRep, we want to solve problems. And we don't just want to sell machines. So please, if you have a problem with CNC, with some kind of fixture, with some kind of prototypes that's not doing what we want to do, it's wasting too much time, or it's not functionally what you were looking for, give Saratech a call, and we're here to support them with all kinds of solutions. Last thing, Abby, I know we just hit the limit, but when we talk about the custom things, I just want to mention we have some automation in the scan to part or the STL to part from a jigs and fixture standpoint. And also one of our most exciting new products is custom, it started from Airbus. So we call it now the Air Box, where you can make custom shipping crates automatically from either a scan part or from an STL, and it will withstand the right G-forces and totally eclipse and protect that part that you're trying to ship. And Airbus needed it because they were getting damaged parts and they were spending thousands and thousands of dollars. Andy, I'm going to throw it to you for the last word.
Great. Thank you, Frank. And once again, I'd like to thank the BigRep team for being here. And I'd like to thank everybody for joining us today. Hopefully, we showed you some useful thing. And, what we challenge you to do is to go back to your work and see what can you do with this technology. And if you need help, let us know. Like Frank said, we're an engineering company. BigRep is an engineering company. Over half of our employees are degreed engineers, and I know BigRep as well. A lot of technical and smart people on board. So we're here to help. And thanks for joining us today, and looking forward to see you in the near future when we can all be in person.
Right. All right. With that, yes, great point there, Andy. So thanks, Andy and Saratech and Frank. Thanks, Chris and Amnon in Boston and Maggie there in New York. And I really hope it felt like we were together. I really did. I felt like I was kind of part of the hurricane there that was happening with Chris there. But as I did mention on the call, our team, volunteer them. If you had a part like the one person that was asking about the injection molding, if you've got a part, our team is great at giving you a part analysis. They can kind of guide you through that process and, let you know their recommendation. Same thing with Andy's team as well. So with that, thank you guys all for being with us here today for this hour. And with that, stay safe, stay healthy, and go BigRep.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.